Hello and welcome back to this second part of chapter 3. And so the second part here starts with charts, and this slide shows you all the different types of charts we'll be talking about. So charts are just a visual way to display your data. And so if you continue on in this major or take the BDAN310 class, that's a visualization class where that's all they concentrate on is how to present the data visually, and they use a product called Tableau. Our product is going to be Excel. So another type of chart is this scatter chart. We've seen that before, and we can actually see the relationship between two variables. It also helps us identify any outliers as well. We can also draw a line between the relationship between the two variables that might be called a trend line. We can also do a line chart. A line chart actually connects the points on a chart. And so you typically would see line charts when you're doing some kind of time series data. And that means that you're collecting data that might span minutes, days, hours, years, and so on. So here's some data that looks at the number of commercials and sales. We'll say number of commercials is going to be our x-axis, and then our y-axis is the sales, which is typically going to be your values of monetary, I should say. So we want to know if a relationship exists or not between these two variables. So the easy way to create this is just to highlight these two columns, copy that to Excel, and then click on the Insert Scatter XY or Bubble Chart in your groups. So I've opened that up on the screen. I typically will highlight the data here. You go to Insert. You could do Recommended Charts and scroll down there and see what they have. So here's the scatter chart. And we can see what it looks like, and it's drawn exactly what you see on your book. Then what you'll click on here, notice how that when I click on the graph, this opens up the chart elements. This will actually do the chart styles, and this will do the filtering. So if I click here, I might want my axis titles. Notice when that open that up, you click on that and then you can edit that from there. To add a trend line, you just right click on one of these points, you click down here and go to, move this up, could add trend line. You probably don't see that, so let me scroll this down. Do a right click, add trend line, and then so you can see what that trend line might look like. So I'll allow you to just follow along in your book. You should practice creating that scatter plot with the trend line. Eventually you should see something like the following. So this indicates a positive trend, so that as the number of commercials increases, the number of sales increases as well. Some other charts that we can create are line charts. So here we have an example of some data. You've got your month, you've got your sales per month. And so again, you would highlight your data, insert, go to your insert tab and go to line chart, and you should be able to create something like this. So here's your scatter chart. And so you can see that, but maybe that doesn't make as much sense to you. If you make it a line chart, then you can see how it adds a little bit more clarity to what the data is doing and how it's moving. You might want to compare sales, and so using the line chart again, we've got monthly sales, and we've got sales in the north, sales in the south. And so we'll be able to create something like this. And so as you create that, you can see what South is doing here. It's the dotted line, and what sales in the north is doing. So near October, sales are going below south, and south continues to increase. And so what your book points out is that if you look at these line graphs appear to be the same until we get to around October, and then all of a sudden what each of the different regions is doing, it changes. So that's the story that you're going to need to tell, and you're going to need to figure out why that happened. You can also put little line charts in your Excel spreadsheets in one cell, and those are called spark lines. And so that just gives you an indication of what that one row of data has done over some time period, right? So keep in mind it doesn't contain any axis. They only display line for the data that's in that row. But it gives the reader or user a quick visual of what was happening over time, because sometimes that's hard to see when you're just looking at numbers. So here's an example of doing a spark line that's at the bottom of the column, so you can see over time what has north done, what has the south done. And we can see that near the end it's dropping, and then near the end it's increasing. The next type of charts we want to talk about are bar charts, and these are horizontal bars that show you the magnitude of the quantitative variable you're looking at. So the only way you're going to show a bar chart is to have some kind of number associated with that data point. You can also have column charts, which are vertical bars to display, again, the magnitude of that quantitative variable. So just keep in mind that when you use bar charts and column charts, you're typically going to make a comparison between categorical variables. So here we have a bar chart for different managers and the number of accounts managed. And so we can actually do a comparison between to see who's managing the most accounts. So it looks like Gentry's managing the most accounts, followed by Lopez, then Francois. And so this would be this categorical comparison. It's not a numerical comparison. We're using those numbers that we've associated with them for those managed accounts here. To bring even more clarity, we could sort this data and the manager that's associated with it to get a bar chart that looks like this, which gives us even more clarity to our information. So I would suggest you go ahead and play with that and see if you can create that same chart, and let me know if you have any questions. You can also add values at the end of your bars, whether that's this bar chart or a column chart. So just add data labels to that. Some other charts you may see are pie charts and bubble charts and a heat map. So the pie chart you're probably familiar with. A bubble chart is a way to visualize three variables in a two-dimensional graph. Right? And this is preferred to a 3D graph because with the 3D graph, it's kind of hard to see the data and you make assumptions about it. And then we also have a heat map, which is a two-dimensional graph that represents data using different shades of color. We'll see examples of each of those. So here we have that same information from the bar chart for the accounts managed, and you can see what you might have there. It's kind of a nice thing to do, but it doesn't convey the information as a comparison as easily as a bar chart does. So given the choice, you should probably use a bar chart over a pie chart. So let's go ahead and create a bubble chart. So let's say we have billionaires per 10 million residents and how much the per capita income is in a bunch of different countries and the number of billionaires. Right, so we can create a bubble chart that shows us this information. And so the larger the bubble, the larger the number of billionaires in each country. So remember what the bubble map is showing us. Go back up here. It's a way to visualize three variables in a two-dimensional graph. That's what we've done here. All right, so see if you can create that as well. So here we have a heat map, and the heat map uses different shades of color. They represent larger data values on the graph here. So here we've got 2% sort of white. As we move up to larger negative percentages, the redder it gets. So here this one is all positive, it's blue, and the higher percentages, it gets a darker blue color. And so you can actually visualize how things are going over time. And we've also got spark lines out the side that visualizes, remember what I said, each row, what's going on each row. And so we can see the St. Louis increasing, Phoenix is decreasing, lots of variability in Albany and Austin and so forth. And the variability means it's going up and down. It's not a continuous trend like you see in Cincinnati. So here, if this is store sales over time, it gives a manager a nice visualization to see if they need to intervene and make any changes to a particular store in a particular city. Some other charts that you may see are stacked column charts, custom column or bar charts, and scattered chart matrix. So the stacked column chart, it's going to allow you to compare values of quantifiable variables for the same category. The clustered column chart is an alternative to the stacked column chart for comparing quantitative variables, and we'll see examples here. And then the scatter chart matrix, when you want to see how different variables compared to each other look. So if we're looking at our north-south data again, we can see that if we use a stacked column chart, how the sales differs between north and south. So we can see that north has higher sales just by the magnitude of the stacked column here. And then what's happening as we get into October, we can see that the north values are declining, whereas the south values are getting larger. So here we have examples of the different types of stacked, clustered, and multiple column charts for that regional sales data. This is the one we were just looked at. Now we have a clustered column chart, and then we have just the column chart for the north, column chart for the south. Sometimes when you're presenting data, it might be easier or better for the reader to see multiple graphs, even though you might have to make them smaller. So to me, the clustered column chart shows that really significant comparison as we get to October, the south is increasing and the north is decreasing. Next, we have some data from New York City subbureaus, and we'll be using this to develop a scattered chart matrix and show the relationship between the different categorical variables. Here's a continuation of that table, so you see all the table that we're using. And then here are the different charts that we might have. So you should note these are scattered charts in the matrix, and so you're going to have this diagonal where there's always going to be a line that's going to be, the data should form a line because you're comparing them to this row 1 to column 1, row 2 to column 2, and so on. So to read this, you're looking at, if we look over here, this is rent compared to college graduates, rent to poverty rate, rent to commute time. And then we do the same with the row 2, and then so this one and this one are the same. Then we just reverse the row and the columns. You can see how that looks. So this one and this one are the same. Row 4 to row 3, and 3 and 4 would be the same. So some interesting things to note is if we look at row 1, column 3, indicates that subbureaus with high poverty rates appear to have lower to medium monthly rents. And if we look at row 2, column 3, the subbureaus with high poverty rates tend to have lower percentages of college graduates. So the high poverty rate here, low graduates down here. So these matrices were created with an Excel add-in called Analytical Solver. We are not using this add-in, so we won't be doing any scatter chart matrix like you see here. But I did want you to be aware of them. Another thing you can do with Excel is you can actually do a pivot chart. So once you've built your pivot table, you can actually do a chart of that table, which is a very nice feature. And so your book steps you through on how to create that. Again, this is something that was covered in the previous MIS class. So make sure you can do those, and the book gives you the step-by-step directions on how to do it, and you should generate something like you see here. And so it shows you how the comparisons between using the restaurant table and how restaurant data and how they were rated. You can see what good does. There's more very good, and then the excellent ones. And then also the colors represent the meal price. And so green here, the 30 to 39, seems to be there is more of a wait time there for that. Some more advanced data visualization you will see is there are special programs that you can purchase like Tableau. There's GIS systems charts that are add-ins or specific programs that allow you to do graphing. I know we won't get into it here, but there is a program called Power Builder, and it's also by Microsoft, and you can download a desktop version, and it's free, and it has a whole lot more graphing capability than what you have in Excel. And you can even go out and find graphs that people have written for certain projects, and they're sharing that now with the Power BI community, and you can use it in your own charting if you want. One advanced type of chart you might hear about is something called parallel coordinates plot. And this chart looks at 2 or more variables, but each variable gets its own vertical axis, which makes it a little different. And so when you're looking at each observation, it's represented by drawing a line on the parallel coordinates of each vertical axis, which sounds, a mouthful, but we'll see an example here in a moment. And then also keep in mind that the height of the line on each vertical axis represents the value taken by that observation. We can also use tree maps. They're useful when you want to look at the entire big picture, and the size of each rectangle in the tree map gives you a comparison to the other variables that you're looking at. Okay, here we have a parallel coordinates plot for baseball data. We have 10 players that play first base, 10 players that play second base. Those 10 are in the red for second base, 10 for first base are in the blue. So this axis represents the number of home runs to a max of 39, and we can see starting out how many home runs each of those different types of players had. The center vertical axis represents the total number of stolen bases, and the rightmost vertical axis plots the player's batting average. So if we could follow that line, we can see the home runs, their stolen bases, and then their batting average. So that's a parallel coordinates plot. So some observations that we see here is that first base players tend to hit a lot more home runs but have fewer stolen bases. We see that by they're all up here, and they tend to go down here for stolen bases. And so in the same sample, then second base players steal more bases, but generally have fewer home runs, although second base players have many home runs and many stolen bases. And then finally, first base players tend to have a higher batting average than second base players. So you can see that again here with the blue lines more up here, and then the average down here for second base players tends to be lower. So that just gives you some idea of what you can do with this parallel coordinates plot. Again, Excel doesn't have this. You're going to have to find that in some other package. Here we have an example of a tree map, and this is for Smart Money's map of the market as an example. So you can see here we have different areas, and within the areas we have even further divided into the tree map, showing a comparison of how large what we're graphing is compared to the other ones that are in that particular sector. And that's what I was talking about earlier, saying you're able to see how big something is compared to something else. So it looks like oil and gas here is fairly big. It's bigger than financials, bigger than healthcare. And then we have utilities over here. It's very small. And then within the utilities, we can see how they compare to each other. Here's another example of a tree map created with the top 100 global companies. Again, depending on what you're comparing, you can see how they compare to each other by the size of those rectangles. And they have different areas here, and then these represent the same areas within that. The last type of maps that you might be exposed to are GIS maps, and they will actually overlay data aggregation on top of a map. So things like I've used before is if you were mapping say where particular types of cancer were by area code, and so you could actually see a map of the areas for those area codes, and then you might use a bar or something else to represent the number of cancers that are in that area. So your book uses this example of this chart of the Cincinnati Zoo member data. And so they can show by the color where the higher density proportion of zoo memberships or visitors are. And you can also use that. Here we have a completed 3D map of the world for GDP data. So we can interact with that if we like. And we can actually get a visual of how GDP is different all over the world. Again, using charts, it's easier to present that data and people then understand it much more quickly than if they were just looking at the numbers, and they can see a comparison. The last thing that you might see or have a need to create for your boss is something called a data dashboard. And a data dashboard uses a bunch of different charts all in one panel or dashboard. So the concept of dashboard came from what you might see in your car's dashboard that shows how your car is handling or what the current status is of certain areas. So might be your fuel gauge. It might also be whether it's hot or cold, how hot or cold is the engine, how fast you're going, and maybe temperature outside. So all of those are in your dashboard in your car. We're just using the same layout or principle here for a business. And so specifically then it shows different metrics on the same panel so that you can make a comparison. Typically, the things that you're going to want on that panel are something called key performance indicators. And so these key performance indicators are things that people want to watch that allow them to know how the business is doing. So it might be something that they can manage on a day-to-day basis or a monthly basis or some other time frame. But when they see that graph, they can tell whether the company is doing well on that key performance indicator or there needs to be some kind of intervention for that. And when you're using those, you want to make sure that you're going to use some kind of color that's going to call attention to the different variables that you're graphing. But you don't want to overdo it either, because then people won't pay attention to what is being changed. So an example of that might be the following. So this is for a Grogan Oil Information Technology call center. So we can see what we're doing in terms of how our calls are going over time and where they're coming from, and then how long the wait is. So we got this graph here for the unresolved cases beyond 15 minutes. And we can see how many of those are and how long they've been waiting. So again, if you're running a call center, then these might be the key performance indicators that you're wanting to know, and they allow you to get an immediate feedback of what you might need to do next. You should know that there are different types of graphs here based on the different types of data and what needs to be conveyed to the user. So we've got clustered bar charts here, horizontal bar charts here, and line graphs here, stacked here. And so you, again, depending on what you're conveying, choose the appropriate chart for that. So that's the main thing you should get out of this chapter. And that ends our discussion for chapter 3.